Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your Unit 5 homework solutions. Question 1, a series circuit has only one path for current flow. Remember, the current is the same through all of the resistors. Question 2, voltage is the force that pushes the electrons through a resistance. Question 3, the total amount of series resistance offered to the flow of current is referred to as the proportional sum of all resistors in the circuit. Question 4, Ohm's law. One example would be I is equal to V divided by R, voltage divided by resistance. Question 5, a series circuit has two 100 ohm resistors and two 200 ohm resistors connected together. What is the total resistance? So remember the expression in series circuits, REQ, which stands for the equivalent resistance, is equal to the sum of all the resistors connected together. So we have four resistors, R1 plus R2 plus R3 plus R4. So I have 200 ohm resistors, 100 plus 100, and then two 200 ohm resistors, 200 plus 200. Plug the numbers in, I should say, add them together. Total equivalent resistance is 600 ohms. Question 6. The total power used in a circuit is equal to the sum of the power used by all parts. In other words, the power supplied by the battery or that DC voltage source is going to equal the power dissipated across each of the resistors contained in that series circuit. Question 7. Voltage dividers are used to provide different voltages across certain points. Question 8. A chassis ground is a point that is used as a common connection for other parts of a circuit, but it is not actually physically driven into the ground. It's just a point of, let's say, a common location. Question 9. A series circuit has individual resistor values of 200, 86, 91, 180, and 150 ohms respectively. What's the total resistance of the circuit? So again, we're going to plug the values in. This time we have 5 resistors, so the equivalent resistance, REQ, R1 plus R2 plus R3 plus R4 plus R5. Plug all those values in, and we should get a total equivalent resistance of 707 ohms. Question 10. A series circuit contains 4 resistors. The total resistance of the circuit is 360 ohms. 3 of the resistors have values of 56 ohms, 110 ohms, and 75 ohms. What is the value of the 4th resistor? So what we're doing in this example, we're given the total resistance of that equivalent value of 360, and we're being asked to solve for the 4th value of resistance. So 360 is equal to R1 plus R2 plus R3 plus R4. Plug the numbers in, solve for R4. R4 is equal to 119 ohms. Question 11. A series circuit now contains 5 resistors. The total voltage applied to the circuit is 120 volts. The total resistance of the circuit is 360 ohms. 4 resistors have voltage drops of 35, 28, 22, and 15 volts respectively. What is the value of voltage on that 5th resistor? So remember, in a series electrical circuit, the current remains the same through each of the resistors, but the sum of the voltage drops across each resistor have to add up algebraically to equal the source or the battery voltage. So we designate that total voltage V sub t is equal to VR1, meaning the voltage drop across R1 plus VR2 plus VR3 plus VR4 plus VR5. Total voltage for the system was given as 120. We plug the rest of the values in and solve for the voltage across that 5th resistor. So the voltage drop across the 5th resistor should be 20 volts. Question 12. A circuit now has 3 resistors connected in series. The resistance of R2 is 220 ohms with a voltage drop of 44 volts. What's the current flow through the 3rd resistor? So the trick to this problem, again, in a series circuit, current is the same. So we simply have to solve for current through resistor R2. So I can use Oh, I can use Ohm's law in this example. Current is going to be equal to VR2 divided by R2. The voltage drop across that 220 ohm resistor was 44. The value of the resistor is 220. Plug the numbers in, and I get a current rating of 0.2 amps. Question 13. A circuit now has 4 resistors connected in series. If each resistor has a voltage drop of 60, what is the voltage applied to the circuit? So again, the trick to this problem, voltage drops add up to be equal to the source voltage. We know there's a total of 4 resistors in the circuit. 60 volts are dropped across each, so 60 multiplied by 4 is going to give me an answer of 240 volts. Question 14. A series circuit is a circuit that has only one path for current flow. The current flow remains the same, and the total resistance, or what we call REQ, the equivalent resistance, is the algebraic sum of all those resistors connected together. Question 15. A series circuit is constructed from 4 resistors with values of 160, 100, 82, and 120 ohms respectively. It is connected to a 24 volt power supply. What is the total resistance of the circuit? So again, we're looking for the equivalent resistance, REQ. REQ is equal to R1 plus R2 plus R3 plus R4. Plug all those numbers in, and we get an overall equivalent resistance of 462 ohms. Question 16. A series circuit is constructed from 4 resistors with values 160, 100, 82, and 120 ohms respectively. It's connected to a 24 volt power supply. What is the total current of this circuit? So in this example, all we have to do is take the voltage given as 24 volts divided by the equivalent resistance, where we add up 160 plus 100 plus 82 plus 120 gives us 462 ohms. Plug these numbers in, we get a current value of 0.052 amperes. Question 17. We're going to use the same value of resistors in the remaining questions. Series circuit is constructed from 4 resistors, again with values of 100, 160, 82, and 120 ohms respectively. It's connected to a 24 volt power supply. What is the voltage across the 160 ohm resistor? In this example, we know the current is 0.052 amps. We calculated that already, so we simply have to use Ohm's law and solve for the voltage drop across R1. So VR1 is going to be equal to the current multiplied by R1. Plug the numbers in. 0.052 multiplied by 160 is going to give us a voltage drop across that resistor of 8.32 volts. Question 18. Series circuit is constructed from 4 resistors with values, again, 100, 160, 82, and 120 ohms respectively, connected to a 24 volt power supply. What is the voltage drop now across the 100 ohm resistor? Same approach. This time VR2 is equal to I times R2. Current is the same. 0.052 amps multiplied by 100 gives us a voltage drop of 5.2 volts. Question 19. A series circuit, again, same value of 4 resistors, 160, 100, 82, and 120 ohms, connected to a 24 volt power supply. This time, what's the value of voltage dropped across R3? Simply plug the numbers in again, same expression. Voltage drop across R3 is multiplied by the current times the value of that resistor, R3. Plug the numbers in, and I get a voltage drop of 4.26 volts. And then the last question, question 20. Series circuit again, 4 resistors, 160, 100, 82, and 120 ohms respectively, connected to that 24 volt supply. This time we want to calculate the voltage across the 4th resistor, so VR4, same current of 0.052 amps multiplied by the value of R4, 120 ohms. Voltage drop across R4 is 6.22 volts. Thank you.